414, which is the third maximum number. So the problem is to find the third maximum number in an array. And what it says is, let's read it out first aloud, because sometimes it kind of helps to read the problems. Given a non-empty array of integers, return the third maximum number in this array. If it doesn't exist, return the maximum number. The time complexity must be in ON. And time complexity must be in ON. ON is saying that we can probably walk the array just once. And I mean, you can walk it twice, but not, you shouldn't walk it like while you are already walking. So that makes it kind of ON square. And but yeah, if you want to walk twice, then if they are not embedded within each other, then it's still ON, because 2ON is still ON only. So let's see the examples. The examples say that the input is 3, 2, 1. Obviously the output will be 1. And when the input is 1, 2, because now we don't have the third maximum number, then you have to return the maximum. So output is 2. And when it is 2, 2, 3, 1, now here it's interesting because 3 is the first max, 2 is the second max. Now you might think that 2 being repeated becomes the third max as well, but no, what he's saying is you have to have the distinct. So here means the third maximum distinct number. So basically it would be 1 again, because 2 is already counted as the second max. You cannot use the another instance of 2 to say that it is third max. So he's saying both numbers with value 2 are considered as second maximum. So it's pretty sounds not convoluted and easy to do. And usually I used to do Python 3. I used to choose Python 3 while trying to do these problems, but today we'll do them in C, because that's the language which is the darling of the embedded crowd. So let's chase our darling, which is C language. So let's try to do that. As you can see, this is the function prototype given to us, and in C, as you can see, the first argument here is basically an array. Now you might say, hey, this looks like a pointer to an integer, but that's no different from array, because as you know, in C, when you're passing an array to a function, you are pretty much, you can either do this or you can do this. So both are fine, basically, pretty much. So that is also an array, because as you know, in C, the array degenerates into a pointer, and such nice things as these are pretty common in C. So what approach should we take to find the third maximum in an array? I guess one thing we can do is we can have a um, a we can have three local variables which are, let us say, initialized to -1, and now you might say, hey, why are you initializing it to -1? What, my array has negative numbers. But I would leave that problem for you to figure out, like what happens if my array is but has negative numbers. But right now, let's assume that the array have array consists of non-negative number. That means 0 or positive. So how do we go about this? In C, it's very easy to to walk in array, or in any language, I guess. So num size, that's the approach usually to walk in array in C. And then what you do is you do this. You say for in I less than I plus plus. Now let's see what should we do. So one thing is, as we are walking the array, we should see that what is the insight here. The insight is that you start by seeing if the current element, which is num psi, is greater than the let's start by first saying first max. Sorry about this. This has to be brackets. All right. So if it is greater, then what we should do? If it is greater, then we have to say that, hey, we have to reset first max, and that should be the current element, right? Similarly, if else if num psi, now if you don't take that root, meaning it is not greater than first max, that means, let's see, is it greater than second max, right? That sounds like a very clean path to basically follow. Or so then we can say, hey, it is greater than second max, and we need to reset the second max. Else we should see, is it greater than third max, and if so, then we just reset the third max. Now before we start celebrating our victory, we have to see that what are the problems that we still have to make sure to hash out. What problems we need to hash out? One is that, look, that what we need to do is that, for example, in the case like, let's just take this case. If you hit a case while we are walking, imagine you are in the middle of your algorithm where everything is working fine, and you find an integer in the array which is actually greater than first max. Then what we need, that as you can see, we already reset first max, but is that enough? Do you see any gotchas here? I see one gotcha, which is that if you reset first max, what happens to the second and third maxes? Because you see, if first max is going to be reset, then you may want to think that the second max becomes, before we override the first max, we need to so if you found a number which is greater than first max, what does it tell you? It tells you that second max has to now be assigned the value of first max before you can override first max. Does it tell or not? I mean, is it obvious or not? Intuitively, you could see that having the having the first max being reset by the current number means that before we overwrite first max, we have to make sure something like this, like second max has to become the first max before we lose the value of first max. And what else we need to have make sure the third max, because now we are overwriting second max, becomes the new um, the new third max becomes old second max. Similarly, in the case like this here, before we overwrite a second max, we have to make sure the third max has become the old second max. And this is fine here. And then we can say, if after the for loop, we should be able to say if third max is still what we started the loop with, then return max, first max basically, as problem states. Problem states that if you don't have a third max, then we have to return the maximum number. Otherwise, we should return the first max. Sorry, third max. Let's see if this one does the job. So say run code, and we have a wrong answer, because what it's saying is that so I deliberately took something which is a little bit complicated. So let's say use a test case which is what we had here. So like for example 3, 2 and 1, and say run code. So as you can see, that one has passed. So you should always start with something that is passing and then try to do something where you start failing. So here we have we can see that it did return, it did do the job. Now let's go to the test case, change it to what we had before. Now here, what do we expect in this case? You see, we were expecting something like, you see 5, 2, 1, 6, 5. We were expecting 6. We were actually expecting 2, because you see the 6 is the maximum number, first max, 5 is the second max. And I think what happened, it failed in this case, this example 3. So example 3 was saying that it should be the distinct max, but what it seems to have happened is that we have gone from 6, 5 and 5. So he said, okay, you got 5 again. He just basically returned that. So now how we can take care of the problem? So I guess if you encounter a number which we have already seen in one of these maxes, so if you say if AI equal to first max, or AI equal to second max, or AI equal to third max, then what should we do? Then we should just continue, I guess, right? Because we do not want to fall into our max reset algorithm if cases where if we have already seen this number before. So if it is a repetition of a number which we have already captured as one of the maxes here, first, second or third, then we just continue. Let's see if that takes care of that case. Compile error. is saying A undeclared. That's easy to fix because I usually have this habit of using A as an array inside functions in C because that's kind of easy to type and you don't have to type lot of typing to do if you use something like nums or add or something like that. So now let's see that one. Now what's the problem? He's saying that you have before this token nums I equal to first max or nums I. Oh, I see here. See, this is the problem right here. It was easy to fix. So there you go. So that basically fixes that. Now let's try to submit and if it passes. So he's saying that that was wrong because of the obvious things that we have. Now you see he has negative numbers and we return 1 and 2. We say, hey, if num size is greater than first max, which was -1. So for example, we would have probably started with 1. So let's do one thing. Let's do this. Let's do a printf here. How we can debug this issue? We can say printf first max equal to this percentage d is the format specifier for integers. Then second max equal to again percentage d, and third max is equal to percentage d as well, right? Then let's see. I mean, it's kind of brute force, I would say, debugging in this case. Sometimes this putting printfs can be quite useful, you know. So let's see what do we get for the case that is failing. So let's say put a test case like that here. And let's see now what happens. There you go. So we started with when we entered the loop. Obviously, we had first max of -1. Everything was -1. So as soon as we saw the number 1, it satisfied our this if statement. 1 is obviously greater than the default that we had chosen for them. So 1 got reset to 1. Second max remained as it is because we only hit one of these if statements. Second times around, we see it becomes 2, 1, makes perfect sense. And then he said, okay, let's return 2, because the third time around, when you would have hit the negative number, what would have happened? If num size is greater than first max, nope, where it's a whole lot more than just like -1. So that condition would not have hit in this case because first max would be minus is 2 actually, and the number your num size would be this negative. I think it's a the most negative 32-bit signed integer, and so we don't satisfy that, we don't satisfy this. Now let's take this case. You are at nums I is this negative 32 raised to the power 32 minus 1, and then you are basically now saying is the greater than third max, which by default you have chosen to be -1, and it is not. So basically we come out, the loop is over, third max is set to -1, we return third max. Third max is -1, so we say return first max, and that's why we are returning 2 here. How can we solve that issue? That issue can be solved in a couple of ways. Number one, what we can do is that we have to have a case here that look, if imagine if you had a case in this case here that if nums I equal to minus 1. Now here this I'm leaving kind of a little bit of a bug, but it would take care of this issue for sure, which is that if it is minus 1 nums I, then we know that nums I have not been assigned any number so far. We are hitting the case of this last if case first time, and then whatever the heck we find, we assign that to the third max. So now you see here, it does work. As you can see, that means we may have to do that over other cases as well. So nums I minus 1 or, so every time we see that, hey, sorry, I think this has to be not nums I equal to minus 1, but more like um, second max. So anytime we see that these maxes are still holding the default values, and I'll come to the bug in this case, then we are okay. So here again, let's do the first max minus 1. That means that we are hitting that if statement first time, because the first max is still holding its default value. Now what happens now, as you can see, this would probably take care of the test case that that Leetcode has this problem, but I wonder if that is a correct solution, which I am suspecting it is not. See, it works, and you might start jumping up and down like monkey, code monkey, but I would say that you should not, because you see the problem here is that using minus 1 as the default, as the value to initialize these maxes to. And why we shouldn't do that? Because what if minus 1 itself was a number in there as one of the inputs in the array? Would that not be an issue? Because you see, that I think should be okay, because you see, if you have minus 1, now let's take a test case here where let's change the test case so that one of the numbers actually is minus 1. And what do we expect the third max to be here? Minus 1, right? Let's see what happens. Wrong answer, because, and that is what I was suspecting, because you see the first max is 2, second max is, and then third max was supposed to be the minus 1, but you're actually returning output of 2. Why? Because of this bug here. See, you said a third max is equal to minus 1, then return first max. What if third max, if minus 1 was a genuine number inside the array? You're assuming that this whole logic assumes that minus 1 cannot occur inside the array. And as long as that is the case, this will work. Now in C, how can we assign the default values to these integers so that that default value should be a value that cannot occur inside our array? And now that is a problem I leave for you to brainstorm, because you know it's good to always keep thinking about uh, an algorithm to see how we can make it better, how we can take care of the corner cases. But for the Leetcode test cases, as you can see, it is basically passing. So there you have it, your third max, and I would encourage you to provide feedback and write some comment. And in the comment, if you can point out how we can take care of the problem when minus 1 is also one of the elements in the array, I would really appreciate it. But until then, while waiting for your comments, I look forward to you're going through this problem, and more interesting brain teasers like this. And I will see you in the next video. And happy coding, adieu, and see you soon. Bye bye.